Let us compare finding the area of a trapezium with finding the area of a rectangle. As a matter of fact, our argument is that a rectangle is also a trapezium, because for an object to be a trapezium, it has to have at least one pair of parallel sides. And as a matter of fact, it has to be a quadrilateral. It has to be a quadrilateral with at least one pair of parallel sides. That makes it a trapezium. Our argument is that a rectangle is also a trapezium. And we are using the area of a rectangle show that it can be found in the same way that we would find the area of a trapezium. And as a matter of fact, consequently, the area of the hypothetical trapezium will be the area of our rectangle that we have right there. So we will treat the rectangle as if it is a trapezium, find its area, and then find the area of the rectangle just as it is, and the areas should be the same. All angles of the rectangle are right angles, and opposite sides are parallel. We know that. Those are facts. Now, if we take a look at this area, the way that we will find the area of the trapezium is that we have b over 2 h1 plus h2. It does not matter what the symbols are. The two that are added inside of the brackets are the parallel sides. Now we have two pairs of parallel sides here, so we can choose any two as the parallel sides that we will make reference to right here. So we'll take the upper and the lower. Those are the two parallel sides that we are considering. The upper and the lower. H1 and H2 are the two parallel sides. As a matter of fact, it does not matter. Inside of the brackets, the two numbers that we have here, or the two symbols, will represent the two parallel sides. So we have chosen two of the parallel sides, and we include them right there. B is the perpendicular distance between the parallel sides. The perpendicular distance between the two 8 centimeter sides is 5 centimeters. The perpendicular distance between these two sides is 5 centimeters. As a matter of fact, since all angles are right angles, any way we look at it, this side will be perpendicular to the two parallel sides, and this, which of course is perpendicular to the two parallel sides that we have chosen, is 5 centimeters. Simplify the arithmetic expression. That is what we need to do. All we need to do now is simplify this arithmetic expression. And we will begin with the two numbers in the brackets. 8 plus 8, that's 16. And we will retain the 5 over 2. Then we will simplify by a common factor of 2. 2 into 2 is 1, and 2 into 16 is 8. Then we'll finish up with 5 times 8, and of course 5 8's 40, but we just have 1 to divide by. Any number divided by 1 is that same number, therefore we can ignore that one. And 5 8's 40, so its area is 40 square centimeters, or we may say centimeters squared. The area of the rectangle is the product of the length and the width. That's the area of the rectangle. So let us include the length and the width. The area is therefore 8 times 5, and 8 times 5 of course is equal to 40. So we have there also 40 square centimeters, or we may say centimeters squared. This is one way in which a rectangle adheres to the properties of a trapezium. So we have treated this rectangle like we would a trapezium in finding the area. It turns out that they are the same. So we are sure that at least concerning the property of area, that the rectangle is actually a trapezium. On this occasion, we will not use numbers, but show that the proposition is generally true, that at least when it concerns the area, that the area of a rectangle may be shown to be the area of a trapezium. All angles are right angles, so we'll just include those. And H1 and H2 are the two parallel sides. A rectangle has two pairs of parallel sides. We may choose any pair, and we are going to choose the lower and the upper. Well, the upper goes first, and then the lower. Do not forget that inside of these brackets, the two parallel sides will be added. B is the perpendicular distance between the two parallel sides. The perpendicular distance between the two representing the length is W, as the width of a rectangle is perpendicular to its length. So the length right here and here, those are the sides that we consider to be the two parallel sides. For a rectangle, the width is perpendicular to the length. Therefore, the perpendicular distance between these two sides that are considered to be the length will be the width. So width is perpendicular to the length. We have no difficulty. That's very convenient for us in a rectangle. So the perpendicular distance between the two parallel sides will be W. And we will go straight ahead simplifying this algebraic expression, and we will say L plus L, that will give us 2L. And we retain W over 2. What's next? Simplify by a common factor of 2, and all that we have left is W times L, which is the same as L times W. Because multiplication is commutative, we are sure that what we have here, W times L, is the same thing that we have right here, and we need not go any further. So we have verified that it is generally true that a rectangle fits the properties of a trapezium. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.